And that's where the pudding is. The pudding is in here. Wait. The proof is in the, yes, you prove the pudding and then you eat it because it's been proven. Welcome back. Today, what we're going to do is we're going to take this thing. It's printing hello world now. It's printing hello world now. So we're going to take this STM32 F746N discovery board and we're going to have it change it up. We're going to vibe code it some changing up and we're going to experiment with some like more intense prompts. I was talking to a good friend of mine last week and he said, yeah, I spend like 15, 20 minutes, half an hour creating my prompt. And I'm like, I spent about 20 seconds creating a prompt. So I took some time before this and I put together a prompt. And we're going to see how, let's see, I think we're using Gemini still. We'll see. We're using Roo Code and Gemini. And we're going to go and then see how it all turns out. So we have our project here before, and what we have is we have a source directory with a bunch of stuff from the STM32. There's a main.c. Over here there's a main.h. There's some other stuff. STM32 kind of like boilerplate stuff that you pull out and you kind of dump in places and then modify. There's an LD file here. We've got our CMake configuration here. Nope, I don't want CMake tools. We've got our CMake configuration here, and then we've got our CMake here where it's got, here's our setting up of our compiler tool chain with GCC and a bunch of Cortex-M assembler base flags, blah, blah, blah. And then it's got the STM32 F7 specific target include directories and whatever. And remember, I didn't make any of this stuff up. Vibe coded it all out. I've created a prompts directory, I should probably say in here to ignore the prompts directory, so we'll see what we've got. So, okay, let's walk through this prompt really quickly, or slowly. You are an expert firmware developer specializing in the STM32 family of devices. The project you're working on is for an STM32 F746N discovery board. The project is built using CMake, as described in the CMake list.txt, found in the root of this project, and in the CMake directory. And the cube library is installed in this directory at the root of the project, okay? So I found that if you don't tell it what's going on, it doesn't actually usually look. It just kind of starts to do things. So what I'm trying to do here in this first paragraph is kind of like set up like, okay, this is where you're entering into. And so I'm not having to ask it to go and, because we're going to have to ask it to go and understand what scenario it's being placed into, okay? So then that's setting up there. So then I'm also saying, okay, the code you may modify is in the core directory. Do not make modifications to the code outside of that. I've seen at times where it's like, oh, I'll go and change this code in the STM732 cube directory. It's like, no. Or it'll go and modify stuff. It's like stick to the core directory. Everything you need to do, you should be able to do in the core directory. But I do understand that you may make modifications to the CMake configuration if it's absolutely necessary to complete the task. I am concerned that it's going to try to include some things in order to accomplish this task from that we aren't currently including, okay? Now, I did kind of scope it down a little bit. My intention was to like have a counter just go toot, 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 and then I'd like tap the screen and then it would reset the counter. Maybe we'll do that next time. But for now, we're just going to stick with what I've got here. So inside the core directory or a source and include directory, the majority of the code is in place for doing the appropriate setup and initialization. Do not make modifications to the setup and initialization code of this project unless you need to add functionality to initialize aspects of the board we aren't using yet, which you shouldn't need to do. I'm trying to scope it down, saying like, don't start messing around with all the initialization stuff. Just focus on what needs to be this one thing. Okay, the majority of the initialization code and business logic for this project is currently in main.c, all right, which is in the source directory. I can put source. While you're executing this task, to keep track of what you're supposed to do in a markdown file and mark off steps as you complete them. We'll be able to resume task execution if we get interrupted. Also, save off the important aspects of this prompt in a markdown file so we don't have to reinitialize the process through a new prompt. if we get interrupted. So that's just setting like, all right, we're gonna put some dishes on the table. We're not even cooking yet. We put the knives out. We're gonna put the plates over here. Here's where the oven is. Like trying to like, welcome to the kitchen. Here's what you can do. Don't do this. Don't do that. All right, now here's where the fridge is. Here's the food that's in the fridge. Don't go to the store and buy different food. Like, stick to what's in here. Your task is this, and I got 5 stages in here. Modify main.c to, instead of just printing out hello world on the board, good job, print out hello world and a counter. This counter should be incremented every second, all right? So then I say, make sure the code compiles and ask me to flash it to the board to verify that it works. Help me debug it if it doesn't, okay? So then it should pause after doing that, and then I should be able to like test it and verify, okay? The next step is then modify the display to use a different background and text colors each time the counter increments by 10. So let's say 10, 20, and so it should change colors of the text in the background each time. Okay, make sure the code compiles and ask me to flash it to the board to verify it works. Help me debug if it doesn't. Okay, and the last thing that I want to do is I want to move the business logic out. So I'm going to do a little bit of design now. If you're doing this personally, you should probably think about your design ahead of time. Okay, we just kind of went and ran with this. And I'm actually kind of asking you to do things backwards. So I'm going to change the design of where the code exists after it already works. And see what it says about that. So we're going to move the business logic out of main.c into another file so that after the system is properly initialized, the control of the program transfers to this new file. You may break up the functions however you see fit. All right. I don't really know what else to say after that. That's kind of, I mean, it's not a Git repository yet, so we're not going to do that and push things up yet, but we could. I know there are certain AIs that do that by default. So yeah, so we're just gonna, that's on my prompt. I'm gonna select this out. I'm gonna head over to Roo Code. Oh, cool. Did I update that already? Oh yeah, probably. All right. Here's a new task. We're in orchestrator mode. We're using Gemini. Paste it in here. There it is. All right. Go. All right. So what has it done? It's done code mode right now. So it's create a firmware task.md to serve as our task tracker. Okay. Interesting. So it did one code and it's going to do both of those things. What did you do? String formatting, declaring a counter variable. Okay. Use apply diff to make these changes. Okay, so the build command is not in build.sh. You'll have to run cmake by hand, preferably without cding into the build directory. One of the things we could do is, well, actually, I don't even know. Is that? Yeah, it's not in there. So I'm not even going to mess around with that. So, yeah, so preferably without cding into the build directory. Okay, enter. Understand. Okay, make dir build. All right, let's see what happens. It built it. Interesting. I didn't say to do that. I said to break that up. I said to verify that I was going to. Okay. I didn't tell it to do that. I told it to ask me to verify it first. I wonder what happened. Let's see. 2 main sections, project context, task checklist. Your instructions are to create this file exactly as specified. After creating the file, use the attempt completion tool to result message indicating the tracking file has been created. Why are you doing something else? You were just supposed to do this one task and then go back. I will notify you upon its successful creation. It did that. I will now proceed with the first task on our checklist. I didn't tell you to do that. Well, let's see. All right, so it's done the tasks. It wasn't supposed to do. I suppose I should. Well, whoa. Okay, now it's doing the fourth one. App logic init. Okay. Okay. And then run logic. Okay. So it did split it up into 2. So there's an init and there's a run. That's interesting. Interesting. I don't know how to feel about this at all. Oh, why did you do this? Okay, automatically includes all.c files. It means that there's included in the build without any changes to the CMake configuration. Do you have Oh, okay, there's an applogic.h. Okay, okay. There it is. All right. And I suppose you moved this applogic init, applogic run. This is weird how this begin while, end while, but you threw it in there, but whatever. It built the main.c, but it didn't build applogic.c. Oh, it's because it's got to remake. Rerun the CMake configuration. There it goes. Okay. Oh my gosh. All tasks on our checklist are not complete. I'll now update and say task completion. Now what are you going to think? What are you going to think? It just did everything. Ay, ay, ay. That's really interesting. It ignored its own commands. No, no, no. Cancel. Let's see what. Firmware task. It checked them all off. You'll notice that all the tasks and the firmware tasks that may have been checked off. Please undo the changes you've done to main.c and help me flash and debug the compiled binary. Yep, that's already done, but whatever. I like how it did it differently this time. It's fine. Open OCD. Nope, I'm not going to do that. I will flash the board on my own and let you know. All right, so I will flash the board on my own and let you know. So let me plug in this thing here. Yes, I'm getting old. Look at that. I'm looking down at it like this. Okay, so that's plugged in there. And then I'm going to plug this in here. Remember that? It says hello world right there. All right, so I'm going to go to my warp console. Okay, please flash the build aware qual bin to my STM32 board. Okay, so that's there. Yes, it was okay to run that. Okay, you're going to reset it. Okay, now it's reset, so it's all white. Reset was set. Now flash again. Erase. Well, I'm going to miss that. That was a working thing, so that's erased. Okay, there's some flashing that happened back there. Buttons are still flashing there. Thinking, thinking, thinking. Okay, now we're going to flash it and write. Okay, flashing little buttons there. Flashing, flashing, flashing. That's taking a long time. It says it was successful. Okay, so verify the write was successful. Confirms. Okay, so then I'll press this button and see what happens. Oh my gosh, it's working. Okay, so it's still there at the bottom, but there now it's in the middle. 10. Oh, and it changed. 19, 20. Oh my gosh, it's working. It's actually working. Now, I wasn't clear in that I wanted the whole screen to change. I wasn't clear about where I wanted the text to put, but it actually made the modification. And it didn't do what I told it to do. I don't know how I feel about this. But it's working. Cut, cut bait, cut bait. Pull the fish out of the water. Let's go, let's go, let's go. All right, so it didn't. I really don't know how I feel about this. Like, it did it, and it didn't do too much, and it didn't go out of bounds. It didn't go all over, but I think it ignored the first third of my prompt. Maybe it didn't. I don't know if you look at, here, let's go back. Let's, it flashed the board, 118, 119, 120. Bam, changes. I didn't give it a lot of explanation, but I mean, it's doing exactly what I asked it to do. You know, so this is crazy. So your current task is compile. Okay. This already is done. All of this is done. So I'm just going to close this and close that. So let's see. Modify the firmware. So it broke it up into tasks, and then the subtask that it broke it up into. Ugh, I really don't know how to feel about this. So the orchestrator did a good job. It broke it up into tasks, but then the first task was to lay out a set of like, okay, that's it. But when it did that, it decided like, oh, well, since I'm here, I'll just keep doing these tasks. I'll actually execute these tasks. And it went through and executed those tasks. But then it didn't actually stop at any point. But the work is done. But then it didn't communicate back to the orchestrator that it. Okay, well, good job, everybody. It works. Nice. Like, keep up the good work. hop down in there and the YouTubers and smash them like and subscribe buttons. And we'll see y'all next time. What the heck is it doing? What the heck is it doing?